So this is a sphere diameter 40 mm, so which is placed, so just draw the sphere diameter is 40, which is placed on the flat surface of the hemisphere. So that means hemisphere means of the diameter is 60, so the diameter is, that means hemisphere means we have to take it half of the sphere, and this sphere need to be kept exactly on the flat surface. So I just select, so I need to find the center. From here the axis point for the sphere center is, diameter is 40, so this height is 20. Now I can place the sphere this point till here. Now this is nothing but an axis point, so this is what this question is. Diameter is 40, hemisphere diameter is 60, so the radius is 30, and the axis length from this point to this point is 20. Now let's see how to draw this. So now you can see that this is the hemisphere, that means a cross section. That means if I'm going to cut it, a circle into half, the cross section is going to be circular, and this one is horizontal surface. So that means first thing is we need to draw circular lamina. That means we need to draw the circular lamina, which is nothing but horizontal surface. In the previous class I told that this is horizontal surface, this is vertical surface, this is vertical surface. Now we need to choose to draw the circle of this horizontal type. So this is horizontal surface, the diameter is 60. That means from this box I need to create a box where from this point 6 boxes, 2, 3, 4, 5, 6. Then from here I'm going to count 3, 4, 5, 6, then 6, then 6. Then we need to join the major axis and minor axis from here to opposite side, midpoint. Then we need to draw an ellipse. From this point I'm going to draw an arc, then from here draw an arc, then from here I will draw an arc, then I need to draw the hemisphere. So this is the center, this is the radius, I am going to draw an arc. So this should be center, this should be the radius, I need to draw an arc. So hemisphere is done. Now we need to draw the axis point. Now from this point I need to count 2 boxes. Then I need to draw the sphere. So sphere, it is very important that sphere we need to draw it in true length. Why? This is cube. When I draw this in isometric projections, you can see that this edge in the front view is an apparent length because the base has been lifted. That is the reason why I will be able to see the top surface. All the edges are in the apparent length. When I am going to take the same thing with the sphere, rotate any angle, the diameter remains the same. So whenever we are going to draw it in isometric projections, only sphere will be in the true length. But when I am going to be drawing the axis, so this is the line, that is nothing but an axis line. If I am going to take this solid, that means I just take one of this pin or stick. You can see that this length is an apparent length in the isometric projections, but whereas if I am going to keep it in the front view, this is the true length. This is the isometric, this is the apparent length. So axis length will be in the apparent length, but whereas the sphere will be in the true length. This is very important when you are going to solve it. So I need to go for circle. I need to draw the true diameter of the sphere, which is equal to 40. So the diameter is 40. Now you can see that when I go to draw it, this sphere will come below this horizontal line, then this is what your drawn is correct. Then here we are not going to retain any construction lines, we are going to retain only what is visible. So this is not seen, this is not seen, this is a construction line, so I will delete or rub all the construction lines. This is how we are going to draw it for a sphere, and this is diameter just for your reference. Do not retain any dimension in case of isometric projections. Sphere will be in the true length.